Okay, riddle me this, students. If you want to cook dinner for yourself and a friend, count equations or calculations upon the success ratio of culinary and gastronomical experiments. Today we will be examining the mathematical probability and equations and calculations upon the success ratio of culinary and gastronomical experiments. Let us begin. No, that's not what you want to do. You want to know how to prepare a recipe that isn't a flop and that actually looks and tastes like it should. Why? So that when you are serving a meal to your friends and family, they, A, will actually want to eat it, B, will think it tastes good, and C, will think you're an awesomely talented individual destined for great things. I'm Matt, the mathematical cook, and I'm here to make sure you measure up in the kitchen.
Wow!
It's like this. Baking and cooking are a combination of math and chemistry. You need the right math, in this case, properly measured ingredients, and you need the right chemistry, which is the chemical reaction of ingredients for a certain amount of time at a specific temperature. Why? Because without it, your pasta may be pathetic, your dessert disgusting, or your cake may look more like a pancake. When cooking or baking, your recipe is your instruction sheet and it includes all the information you need for a successful outcome. Typically, the recipe is divided into 3 distinct areas. The top area would have the name of the recipe, perhaps the oven temperature if the recipe calls for baking in an oven, and the quantity the recipe makes. This is sometimes called the yield. This can be the number of pieces, as in a cookie recipe, or how many servings if the recipe is a stew or a casserole or a cake, for example. The middle area shows the ingredients you will need. These are the fruits, the vegetables, meat, spices, liquids, etc., and how much of each one. You have to know what the abbreviations mean and what measurement tools to use. The bottom area shows the directions. This is the blueprint for putting the ingredients together to make the recipe successfully. It is important that you understand all of the cooking and baking terms and follow the instructions exactly. Why, the first time I made Jell-O, I was a wee lad. I used warm water instead of boiling water to dissolve the gelatin, and cool water instead of cold water in the next step. Gosh and begorra, what a flop. I created a gelatinous soup, but it was a lovely shade of green. The moral of this story, follow the instructions even if you think they don't make any sense. If you understand the measuring tools on the abbreviations, you will be able to measure and add the ingredients with accuracy and precision, thereby increasing the probability of a successful cooking experience. Good cookie. When you're figuring out a mathematical problem in the kitchen, do you use a calculator? Of course not. The food would get in between the teeny tiny keys, and then they'd stick. Not very practical. Ow! You use measuring spoons, measuring cups, and measuring pitchers. Measuring spoons typically come in 4 sizes: tablespoon, teaspoon, half teaspoon, and quarter teaspoon. Measuring cups would be used to measure dry ingredients like flour and sugar, or solid ingredients like shortening or peanut butter. They come in sets of 4, 5, or 6 pieces. They all include a 1-cup cup, a half cup, third cup, and a quarter cup. Sometimes you'll see a 3/4 cup and a 2/3 cup size as well. Liquid should be measured in measuring pitchers. These usually have cups and ounces marked on one side of the glass or plastic pitcher, and metric measurements in liters and milliliters on the other side of the container. What's the difference between a teaspoon and a tablespoon? Well, obviously one is larger than the other one, but in a recipe, that small size difference can turn into a really big deal. Maybe not if you're putting 3 teaspoons or 3 tablespoons of chocolate syrup into, say, vanilla ice cream, but if you're putting 3 tablespoons of salt in a soup, yuck. or 3 tablespoons of chili powder in a noodle dish, watch out! You can remember that a teaspoon is smaller than a tablespoon because a teacup would sit on a table. And you can remember that there are 3 teaspoons in a tablespoon because there are 3 letters in tea. When your recipe calls for an amount of something and you don't have the exact measuring tool you need, sometimes the solution is simple. If a recipe calls for 2/3 cup of shortening, you only have a 1/3 cup measuring cup, you just use it twice. But what if the recipe calls for a 1/8 cup of shortening and the smallest measuring cup you have is 1/4 cup? Trying to eyeball it won't be very exact, but if you know how many tablespoons are in 1/4 of a cup, you can use your tablespoon measures. Or if you are increasing a recipe and it calls for 8 tablespoons of cooking oil, you can either go measure, pour, measure, pour, measure, pour 8 times, or you can measure it in a 1/2 cup once and be done. Here are a few equivalents you may want to memorize. 3 teaspoons in 1 tablespoon and 4 tablespoons in 1/4 cup. Old recipes sometimes call for a dash or a pinch or a speck. That is less than 1/8 of a teaspoon. Here's a way to measure the liquid measurements. Gallon is the biggest. Inside a gallon go 4 quarts. Each quart gets 2 pints. Each pint gets 2 cups. GQPC. GQPC. How can we remember that? Let's see. Gargantuan, quarts, pour clumsily. Good queens pray continually. Grandma, Quincy, plants carrots. Well, whatever works for you. Use it. When following a recipe, it's critical to understand the measuring terms used, as well as know the abbreviations. If a recipe asks for 2 tea and you put in 2 teaspoons, you may wonder why the flavor is weak, unless you remember that a capital T is the abbreviation for tablespoon. On the other hand, if the recipe calls for 2 tea and you put in 2 tablespoons, you may have a flavor so powerful it ruins the recipe. As you try more recipes, you will start to note similarities. For example, in baking, flour and sugar are usually the 2 ingredients you use in the largest quantities and are usually measured in cups. Other flavorful ingredients like salt, spices, and seasoning are typically used in very small amounts and are almost always measured in teaspoons. If your Aunt Tilda's handwritten cake recipe calls for 2 tea or teaspoons of flour and 2 C or cups of cinnamon, you should immediately know that doesn't make any sense. Check your recipe source. And don't say anything about Aunt Tilda's bad handwriting. It may hurt her feelings. Let's look at a few more family recipes and see if we can spot anything. So, what is wrong with Grandma's muffin recipe? Well, I'll tell you. It's the flour. The small t should be a capital C for 2 cups, not 2 teaspoons. Flour is a primary ingredient in many baking recipes and would be used in a much larger amount than 2 teaspoons. Let's try another family recipe. Now, if you serve this spaghetti sauce to Uncle Leo, you might soon be sleeping with the fishes. Why? 1 cup of salt. Salt is a seasoning and should be used sparingly. The actual recipe calls for 1 pinch, about 1/8 of a teaspoon, of salt. Let's try one more family recipe. In Cousin Bertie's banana bread, the wrong ingredient is 1/2 cup of baking soda. Baking soda is a leavening agent used in doughs and batters to cause a foaming action, which lightens and softens the finished product. It is used in small amounts, and in this case, it should be 1/2 teaspoon instead of 1/2 of a cup. Even if you don't know that it should be 1/2 teaspoon, you should certainly know that 1/2 cup is too much. Check with Cousin Bertie or compare it to another similar recipe. You can remember baking and cooking are a combination of math and chemistry. You need the right math and you need the right chemistry. Okay, riddle me this, students. If you want to cook dinner for yourself and a friend, and the recipe you want to use serves 6, what do? 6 servings divided by 2 people is 3. So you would take the recipe and divide by 3. Or if you're having a dinner party with 12 people and your favorite potato recipe serves 4, multiply by 3. If you know how to accurately change the measurements in recipes to make it feed more or less people, your guests will be happier and you won't be cooking portions that are too large or too small. Sometimes it's easy. You multiply or divide by 2, but what happens when you want 2/3 or 3/4 of a recipe? This is a 3-2-1 recipe, which makes pie crust dough. To make 1/3 of this recipe, you would divide each measurement by 3. 3 divided by 3 is 1 cup. 2 cups divided by 3 is 2/3 cup. And 1 cup divided by 3 is 1/3 cup. What you'll do whenever you increase or decrease a recipe is divide or multiply all of the ingredients by the same amount or same ratio. My advice is to write it all down first, rather than do the conversions in your head as you work. Doing in your head is risky business when you've got a pot boiling on the stove or something in the oven. If you don't increase or decrease all of the ingredients, your recipe won't turn out. Let's practice. Let's see if we got the same answers. Half a cup of butter doubled is 1 cup. To measure butter, you can use the handy-dandy markings on the paper wrapper. Instead of 1 green pepper chopped, I have 2 green peppers chopped. The sliced mushroom calculation is a bit tricky. You have to know that there are 8 ounces in a cup. 3 ounces doubled is 6 ounces. 6/8 ounces is the same as 3/4 ounces, which is the same as 3/4 of a cup. Doubling a half a cup of flour is 1 cup of flour. To measure dry ingredients such as flour, spoon the flour into a cup and level it off, or lightly scoop and level it off with a knife. Do not pack the flour. Doubling the salt gives us 1 teaspoon of salt. To measure salt, pour it into the teaspoon when it is over an empty container and level it. If you overpour the salt, you don't want it to go into your recipe. Black pepper increases from 1/4 of a teaspoon to 1/2 of a teaspoon. Once again, pour it over a container and level it off. Doubling the milk changes it from 1/2 a cup to a full cup. Make sure you're at eye level when you measure liquids. Chicken broth doubled becomes 2.5 cups, so you will have to use a measuring pitcher like this one. To be precise, you should get your eyes down to the level of the liquid. It will form a little downward curve called a meniscus. The bottom of the meniscus should be lined up with a 2.5 or 625 milliliter line in this case. These measuring pitchers usually have metric measurements on one side for easy conversions. The 2 cups of cooked cube chicken, when doubled, becomes 4 cups of cooked cube chicken. Use the dry measuring cups for this ingredient. The chicken should be firmly packed in the cup, but not smashed into the cup. Firmly packed, not smashed. So this is a doubled recipe. But what do you do if you want to serve 2 people? Because the original recipe serves 6, you will divide by 3. 6 divided by 3 equals 2 servings. While you are figuring that out, I'll make this recipe. Hey, you were fast. Me too. Let's see how you did. When you divide the 1/2 teaspoon by 3 and get an amount smaller than the smallest teaspoon, so we'll call that a dash. To measure a dash, pour a tiny bit into your palm, then pinch it and toss it in. You shouldn't skip the dash ingredients because they do add flavor. Here is the finished dish. Properly measured, carefully cooked, ready to eat. Yum. Let's try another recipe. Now, this spaghetti recipe, it serves 8 people. How would you change it to serve 12 people? The spaghetti sauce recipe isn't tough to double, but here's a tip. When you have an oil as well as other ingredients to measure, do the oil first. That way, the oil coats the inside of the spoon or cup, and the other liquid ingredients will slide right off the spoon or cup. To increase this recipe from 8 to 12 servings, you should multiply it by 1.5. The measurements are 1/4 cup plus 2 tablespoons olive oil, 9 cloves of garlic chopped, 4.5 cans of crushed tomatoes, 1/2 to 3/4 teaspoon of salt, 4.5 teaspoons of dried parsley, 12 leaves of fresh basil without the stems, and 1.5 cups of water. Okay, let's pretend that half of your friends couldn't come. So, this recipe that serves 8 should now serve 4. Take time now to convert the recipe. Now this is how your spaghetti will look when it's all measured correctly and cooked according to directions. Magnifico! And here are the measurements for serving 4 people instead of 8. I have another tip for you. When the recipe calls for a can of something, there is a standard can size which is 14.25 ounces. If you use a larger can than that for the recipe, it'll turn out bland because you have too many tomatoes in relation to the spices. It's all about the ratio of ingredients to one another. I have one more recipe for you to convert. Instead of making 4 dozen cookies, change this recipe so you will get 3 dozen cookies. This conversion was a little more difficult. To go from 4 dozen, 4 times 12 equals 48 cookies, or 4/4 of a recipe, to 3 dozen, 3 times 12 equals 36 cookies, or 3/4 of a recipe, you will subtract 1/4. Another way to look at it is to divide the ingredients by 4, and then multiply each unit by 3. Here's what you should have come up with to reduce the recipe to 3 dozen cookies. 2 eggs is a little tricky. To reduce by 1/4, you'll need to go to the common denominator, which is fourths. 2 eggs equals 8/4. Then divide by 4 and multiply by 3, which gives us 6/4, or 1.5 eggs. To measure it out, beat the eggs slightly and then keep 3/4 of the mixture. You can either eyeball the 1/4 that you remove or use measuring cups to scoop out about 1/4 of the mixture. Flour is 1 7/8 cup, or 1 1/4 cup plus 2 tablespoons. Baking powder, 3/4 teaspoon. Salt, 1/4 teaspoon. This is an estimation because the measurement is too small to be more accurate. And baking soda, 1 teaspoon. This measurement is also too small to be more accurate. I have one more conversion for you. Convert the peanut butter cookie recipe to one which makes 12 dozen. While you're doing that, I'll make these cookies. Wow, these were fast. You know, these cookies are really, really good. They're good because they were measured and baked properly. They measure up. And this is what your 12 dozen cookie recipe should look like if you multiply everything by 3. This makes a lot of cookies, so you'll need a very large mixing bowl. Easy sneaky, right? You give Matt a cookie, he's gonna want some milk. Before you ever make a recipe, you shop for the ingredients, right? The tricky part is that the ingredients come in a variety of different types of packaging. Getting the best price means comparing the cost of different sizes and weights of packages. You'll need to know two things to determine the third. You'll need to know the cost of the ingredient and the size or number of units to calculate the cost per unit of measurement. Say again. You'll need to know the cost of the ingredient and the size or number of units to calculate the cost per unit of measurement. The mathematical calculation will be the same, regardless of whether you're using imperial measurements like pounds or ounces, or metric measurements like milliliters. You still need to divide cost by number of units. I recommend using a calculator. The one on your phone could work, but if you can do this in your head, go for it. Let me give you an example. To understand the true value of the item you are looking at, you need to compare apples to apples. This 3-pound bag of apples is $3.67. This 5-pound bag of apples is $5.49, and you can bag your own apples for $1.37 per pound. How will you know which one to buy? Which has the best price? Option number 1, option number 2, or option number 3? Let's do the math. Option 1, $3.67 divided by 3 equals $1.22 per pound. Option 2, $5.49 divided by 5 equals $1.10 per pound. Option 3, $1.37 per pound. The winner is option number 2. Once you know the unit price, cost per unit of measurement, you can make the best decision. Sometimes it is worth it to buy the slightly more expensive options if buying the less expensive option leaves you with a lot more leftover ingredients. On the other hand, if it's an ingredient you use frequently, it's better to get more than you need right now if it's cheaper per unit. Unless 5 pounds is way more apples than you could ever use or need, option number 2 is your best buy. Let's try another one. You need canned peaches for a school lunch. All right, I know. Pretend this is a good thing, okay? We've got our option number 1, our option number 2, and our option number 3. Option number 1. 4 individually packed 4-ounce single-serving peaches for $1.89. Option number 2, a 15.25-ounce can for $1.18. Option number 3, a 29-ounce can for $1.29. Which option gives you the best price? Ding, ding, ding! Time's up. The calculations are as follows. Option number 1, $1.89 divided by 16 ounces. That's about 12 cents per ounce. Option number 2, $1.18 divided by 15.25 is 8 cents per ounce. Option number 3, $1.29 divided by 29 is roughly 4 cents per ounce. In option number 1, you are clearly paying for the convenience as well as the peaches. Option number 2 is a good price. And number 3 is an even better price, but a large size. You may want to choose between option number 2 and number 3 and pick the size that works best for your recipe. Let's try another example for a recipe in which you need 2 pounds of ground beef. All right, here's how the ground beef cooks up. Okay, we've got 2 little packages, and number 1, we've got our medium-sized tube of ground beef, and our third option is a great big tube of ground beef here. Fresh ground chuck, excellent. Option number 1. 2 1-pound packages at $3.92 each. Option number 2, a 3-pound tube at $9.88. Option number 3, a 5-pound tube at $14.98. Which option gives you the best price? Here's how the ground beef cooks up. Option number 1, $3.92 per pound. Option number 2, $9.88 divided by 3 equals $3.29 per pound. Option number 3, $14.98 divided by 5 gives you $3 per pound. If you have space to save the pounds of ground beef that you don't need, clearly the 5-pound package is the best deal. We have time for one more cost comparison. This time, you're going to make sandwiches. Now, which option gives you the best price? All right, we've got this loaf of bread and the larger loaf of bread here for number 2. And for our sandwiches, we've got a package of hamburger rolls. Option number 1, a 1.5-pound loaf with 16 slices for $1.99. Option 2, a 1.5-pound loaf with 24 slices for $1.68. Option 3, a package of 8 sandwich rolls for $2.69. Which gives you the best price? To be the sandwich king or queen, you would be looking at the following choices. Option number 1. It gives you about 8 sandwiches, 2 slices per sandwich, for about 25 cents per sandwich. Option number 2 gives you about 12 sandwiches for about 14 cents per sandwich. Option number 3 provides 8 sandwiches for about 34 cents each. Now, unless you have a strong preference for the rolls, option 2 is the best buy. So, if you choose option 2, you are now king or queen of sandwiches! Hey, master of the calculator, master of kitchen measurements, congratulations! Way to go! You measure up. Good work. Bueno! Everybody mambo. Oh, yes! Checks in the mail. Way to go! Boy, what a mess. Okay, riddle me this, students. If you want to cook dinner for yourself and a friend, Bun's equations or calculations, a Bun's success ratio.